All right, what better way to spend a Friday night than doing some live coding, of course. And let us, your audience will see it in a moment. Get ready. All right, I'm ready. So let us look at this day 8 problem. Day 8, memory maneuver. So let us make a file, day 08, memory maneuver.py. That's one of those things I can't spell well. The sleigh is much easier to pull than you expect for something that its weight. Unfortunately, neither you nor the elves know which way the North Pole is from here. Check your wrist device for anything that might help. It seems to have some kind of navigation system. Activating the navigation system produces more bad news. Failed to start navigation system. Could not read software license file. The license file consists of a list of numbers. Your puzzle input. The numbers define a data structure, which when processed produces some kind of tree that can be used to calculate the license number. The tree is made up of nodes. A single outermost node forms the tree's root, and it contains all other nodes in the tree, or contains nodes, it contains nodes, or so on. Specifically, a node consists of a header, which will always be exactly 2 numbers, the quantity of child nodes, the quantity of metadata entries, 0 or more child nodes, 1 or more metadata entries. Each child node is itself a node that has its own header, child nodes, and metadata. For example, each node of the tree is also marked with an underline, starting with a letter for each notification. In it, there are 4 nodes. There's node A, which has 2 child nodes, B and C, and 3 metadata entries, 1, 1, 2. Okay, B, so A has 2 child nodes, B, which has 0 child nodes and 3 metadata entries, and okay, C, which has 1 child node, 1 metadata entry, D, which has 0 child nodes and 0 metadata entries. The first check done on this license file is to simply add up all the metadata entries. In this example, this sum is 1 plus 1 plus 2 plus 10 plus 11 plus 12 plus 99. What is the sum of all metadata entries? Okay, so this is just a little parsing thing. And here's, let's stick this here. So I think I have an idea of what to do. Day 08.text, and let's paste this there, and it's all on 1 line. Okay, so that's fine. I probably spelled maneuver wrong. That's one of those words that I can never spell. Maneuver, nah, looks all right. Okay, so here we have again a raw input, which I'll do like that, and let's just turn it into ints. Input equals int of x for x in raw.split. Okay, so if I do IPython and I run day 08 and I check the input, okay, so I've got a list of numbers. And so as always, the F key on my keyboard is not working very well, so that's bad. From typing import named tuple, I'll try and use as few F's as possible. One person watching, hi. And so what we've said is, like, my named tuple style of modeling that I love to use is totally perfect for this. And that's as follows. And so we're calling this a node, class node, which is a named tuple, and we have num children, which is an int, and then we have num metadata, which is an int, and we actually don't need these. So children is a list of nodes, and metadata is just a list of ints. And so we actually don't need num children and num metadata. Okay, and so parse nodes, and that will take inputs, which is a list of ints, and it's just going to return a single top level node. And so what we're going to do is so let me do this. Num children. I said I wasn't going to need this, but I think I am going to need this. And num metadata is an int, and then somehow I deleted my metadata, which is a list int. Okay. And so I'm going to make a stack, which is a list of nodes, which is just empty to start with. Yeah, and so here's the idea. The idea is when we get this, we want to pull off the 2 and the 3. So we'll say num children num metadata equals inputs 1 and 2. And let's say node equals node num children num metadata, and I'll just put empty list here as placeholder. So, and let me call this, I'm going to call this get node. And I'm going to, let's think about this. So what do I want to do? Now I have inputs equals inputs 2. Shouldn't do that. That's inefficient, but we don't have that many inputs, so I don't care that much. And so what do I want to do? I want to do for I in range num children. So let me do the following. And I hate doing this, but I'm going to do it anyway. Is that when I do this, I am going to throw away. No. Let me think about this for a minute. Okay, so I say I have 2 children, I have 3 metadatas. Now I go here, and I just want to keep going. I say I have 0 children and 3 metadatas, so I pull off 1, 2, 3 metadatas, and then I'm done with a node, and then I want to add it as a child, or let's say I collect him, and then again 1 child, no metadata. Here's his child. So children metadata 0, 3, 10, 11, 12. That's good. 1 child, 1 metadata. This child is this guy, and then he has that's the metadata, and then so this is in okay, so I've got it. So let's say that the metadata is going to be, okay, good, is going to be the last num metadata things of this, right? So so here I say I have 2 children, 3 metadata. So that means that the metadata is going to be the last 3 elements of this. And so then inputs equals inputs 2 to minus num metadata. That's fine. And I might skip doing that. And so what I want to do is, so I want to get, so I do that, and then so I think that's okay. So let's think about this because I'm approaching it all wrong. So 2 children, 3 metadata, pull off the metadata. Now I need to get 3 children out of this thing. I get 3 children by let's look at that example. A, which has 2 child nodes and 3 metadata entries, that's fine. B, so I can't do this. So what I need to do is the following. Current node equal. So this is right. And let's just say start int equals 0. Start to start plus 2. And let's say for I in range num children. No, that's not going to work either. Okay. So the sad thing is that this is almost assuredly not a hard problem. And again, this is one of these things where I'm too tired to figure it out correctly. So let us think through this in detail. 2 children, 3 metadata. So that means stick it on there and find a child. Okay, so I think the stack was the right idea. List of node equals this. And num children equals none, num metadata equals none. So let's say for I in inputs, if num children is none, num children equals I. If num metadata is none, num metadata equals I. And node equals node num children num metadata that let's see, current node is none. So let's say current node equals that. And then what do I want to do? 2, 3, then I keep current node is that. Now I make, and I want to pop him on the stack. So let me think about this from the inside out. Yeah, this can't be good watching today. So, okay, I'm failing the interview, which is always a fun sign. Let me just copy this over, which might make my life easier. Will help to have it to look at without having to go back and forth. So let's think about this. If I were solving this problem myself, I'd say 2 children, 3 metadata. So that's good. Pop that off on a stack somewhere, and let's start over and find a node. 0 children, 3 metadata. And because it has 0 children, or because it has all its children, then I'll add its metadata, and then I will add it as a child to the previous guy, and if he has all his children, I will add him as a child to the previous guy, and then so on. Okay, so let me, so I think that's the idea, and the question is, can I make it work? I equals 0, while I less than len inputs, okay? So, and let's say current node is none. Actually, no, let's say current node is node inputs 0, inputs 1, empty list, empty list. Okay. And then we'll start at I equals 2 and say, and I'll just use a 4. I in range 2 len inputs. Okay, so I think this will possibly work. And so what I want to say is, if actually let's do it the other way, it'll be easier. I equals 2 while I is less than len inputs. All right, I've already wasted 20 minutes, which is good. If so we have a couple cases. If current node dot children. So if the length of current node children equals current node, let's start on the other way actually. If length of current node dot metadata equals current node dot num metadata, so that means we're actually done with this node. So this node is finished. So what I want to do is, no. I thought I had a good idea, and I didn't have a good idea. So, okay, 2 children, 3 metadata. Add him to the stack, and now start finding a child. 0 children, 3 metadata. So now, no. All right, let's think about how to do this. This really shouldn't be hard, and I'm feeling pretty stupid that it is being so hard. So, num children, num metadata. Push that on a stack, and then num children, num metadata. Push that on a stack. So num children, num metadata. So now I need to find 2 children and 3 metadata. So to find 2 children and 3 metadata, I can pull the 3 off the end, and then find the 2 children in the beginning. And to find 2 children, I just find 1 child and 1 child. So make node inputs list int num children int num metadata int and node. So maybe this will work. So what do I want to do? I want to say metadata equals inputs minus num metadata. So I want to find 2 children and 3 metadata here. I pull off those 3 metadata. So now I want to find 2 children. So maybe I can do this. Def find in children, inputs is a list of int, num children is an int, and this is going to return a list of nodes. So here we can think about it being this. And so what I want to do is say so this might work. What I want to do is say no, it's not going to work. Okay, so maybe if I just work through this in grueling detail. So 2 num children, 3 num metadata. So now find two children, 0 num children, 3 num metadata, and now I want to find 0 children, and I'm done. So 0 children is easy. Find 3 metadata. That gives me 10, 11, 12. And so that's found one child. And then I want to find another child. So 1 num children, 1 num metadata. So find 1 children, and the 1 children is 0 num children, 1 num metadata. Find the 0 children. That's done. Find 1 metadata, which is 99. Okay, so found 1 child, and then I need to find 1 metadata, and that is going to be 1 metadata 9. Found 1 metadata, which is 2, and then find 3 metadata, and that's 1, 1, 2. So the question is, how do I turn this into it certainly does. But it's not that simple, because you have to make a recursive call to find multiple children in one call. So this is the right idea. The trick is just juggling it and making it work. Use it. So what I need to do is basically get nodes, inputs is a list of int, and I'm gonna have to do something like starting position is an int, and it's going to return, and I have to think about this, a tuple of a node int, where it's going to tell me basically where I left off. And so this is going to be the tricky thing to juggle, is that I want to say, num children equals inputs start, num metadata equals inputs start plus 1, and for blank, and so let's say children equals this, for blank in range num children, and so what I want to do is I want to say child comma start equals get nodes inputs start plus 2, right? So I'm basically going to need to return where do I pick up when I come back. And that was the part that I was really struggling with. And I think this will probably work. And say children dot append child. And so let's see if this works. And now what I want to do is for blank in, and so metadata equals inputs, and now we have a new start again, start plus num metadata, and return node of num children, num metadata, children metadata, and start plus num metadata. Okay, so it's this returning where to pick up thing, which I think is the tricky part. But and let's just say start int equals 0. So like for instance, this 0, 1, 99 was get node 0, 1, 99. So that'll give me a node with, and the metadata is, so that's wrong, but it's doing something kind of interesting. It got this right, its children is empty. And so I think what happened, so let's see, print inputs comma start, and okay, so I get there and it's doing the right thing. Child start equals get nodes inputs, so it did nothing. So let me do this. I think this will make it work. Yeah. Get nodes input comma start. Actually, I think this is fine. Start equals start plus 2. And then do I need to add? No, I don't think I need to add another 2. So let me try running that again. And that gives me 0, 1, children 3, which I think is right. So now, what happens if I do get nodes input? So I get 1 node with 2 children, 3 metadata, 0 children, 3 metadata, 10, 11, 12. Okay, so this is, this I think is right. And yeah, not my best. Okay. But I think I'm making progress now. Okay. So now what are they asking us to do? We want to do the sum of all the metadata entries. Sum all metadata root node, and that'll give me an int. And that will, what do I need to do? Let me get rid of this unnecessary print statement up here. Return sum of node dot, or sorry, I'm just calling it node instead of roots. Sum of node dot metadata plus sum of sum all metadata child for child in node children. And so now I want to assert that sum all metadata of, so let me do node equals get nodes of input, and I want to assert the sum all metadata of the node is 138 is what they want it to be. So let us run that test. Tuple has no attribute. Sum all metadata child for child in node.children. Okay, so that didn't work. So let's print node. So that returns node comma blank. And that assertion passed. So that makes me think that we've done it correct finally. So now, with open data day 0 8 dot text as f, raw equals f dot read dot strip, inputs equals int x for x in raw dot split. Node something equals get nodes of the inputs, and then I want to print sum all metadata of node. So let's run this, and there's an extra print somewhere, and it is here. Okay, so if I look at node, it's this nasty thing, but it actually did parse, and so the fact that it parsed is a good sign, because if we did something wrong, it would not have parsed. So let's stick this in and see what happens, and that is the right answer. Okay, good. Okay. The second check is slightly more complicated. You need to find the value of the root node. The value of a node depends on whether it's child node. If a node has no child nodes, its value is the sum of its metadata entries. However, a node does have child nodes, the metadata entries become indexes, which refer to those child nodes. Metadata entry of 1 refers to the first child node, 2 to the second, 3 to the third. The value of this node is the sum of the values of the child nodes referenced by the metadata entries. If a reference child node does not exist, that reference is skipped. Child node can be referenced multiple times. It counts each time it's referenced. Node C has one metadata entry 2. Node T has one child 2 does not exist. Blah blah blah. Node A has 3 metadata entries. The one references node first child 2, second child, and so on. Because B has a value of 33 and C has a value of 0. This is this. So if a node has no child nodes, okay. So okay, good. Now that we've built the nodes, let's see. So now that I've, this part should be easier because the hard part was building the tree. This is just processing the tree. So I want to do a function that does the value of a node, which is a node, and that's just going to be an int. And so what they say is if node.numChildren equals 0, so if a node has no child nodes, the value is the sum of the metadata entries. So return sum of node.metadata. Okay, and then otherwise, let's just say val equals 0. Otherwise, return sum. I'll see if I can do this in one line. I probably can't, but for index in node.metadata. So what do I want to do? I want to say value of, let's say child values equals value, here we'll do this. Child values equals I value of node, value of child, for I child in enumerate node.children. So I'll make it a dict so that I can look it up. And then, and I'm going to do it this way so that I'm not like recomputing stuff a lot of times. And I can say return sum of child values dot get I comma 0 for I in node.metadata. So basically, I'm just going to compute the value of all the children, and now I'm going to look at the metadata, and for each of them, if it's valid, I'm going to just grab that from here. Otherwise, I'll use 0, which I think is what it said. And so now they're saying that the value of the root node is 66. So let's say value of node equals 66. So let's run that and see if it node has no attribute children. That's interesting because you would think it would. So let's think children. Okay, I can't type real well. And that's assertion error, so that's no good. Value of node is 0. So let's look at node. Okay, so this is easy. Let's do a little bit of debugging here. Print node. And we run it, and so I do this node, and now print CV child values, print using metadata, sum node.metadata. So let's run this again. So I have this node, I have this node which is using metadata 33, and this is metadata 99, so let's print and print metadata node.metadata, and let's figure out what I've done wrong here. I'm sure it's something simple. So that gets me nothing. This gets me 1, 1, 2, and that gets me okay. So I think I've probably misread. Node C has one metadata entry 2. Because node C has only one child node. 2 references to child nodes exist. Value of node C is 0. Node A has 3 metadata entries. 1 reference is B, and the 2 references C. B has a value of 33, and C has a value of 0. So the question is, am I see. So I can't index N. I need to do I minus 1, right? Because when it has a 1 here, it wants me to be getting the first one, which is the one in position 0, and as a 2, it wants me to get the second one, which is the one in position 1. So that's the issue, is that it's using a funny kind of indexing, and I bet once I make this change, it's going to work. And you can see it that my assertion passed. So now print value of node. Okay, so now let's run it again, and it says 20849. So let us go and plug that in, and that is the right answer, rank 872. So okay, so we got off to a very bad start, but then we finished strong. So thanks for watching, and github.com /Grus2018. So, you know, find me on Twitter, find me on YouTube, find me on Patreon, whatever. And yeah, so we got it figured out. Let me think about why this was so hard, because this definitely was harder than I thought it should be, and you know, this ends up not being that much code. So I think the conceptual thing I really got stuck on is that, like, I wanted to make a recursive call, but Here I can say, all right, that's fine. I need 2 children, 3 metadata. Let's make a recursive call. But it's a funny kind of recursive call because I need to get 2 children out of it, and the subproblem doesn't look exactly the same. And so the key thing that I really needed to do that took me a while to figure out was that I need to, one, pass in where I want to start so that, once I go here, I can say, find me a child starting, at position 2. And then, just as importantly, I'm going to return where I ended up at, right? So I make a recursive call that says start looking for a child at position 2, but once you find one, tell me where you left off so that I can then make another recursive call, at position 3, and then only once that comes back, work with the metadata. And so that was kind of my weird conceptual sticking point that I got really unfortunately hung up on. So thanks for bearing with me, because it can't be that exciting to watch me get stuck and puzzle through these things. Or maybe it is, I don't know. And now the code is up on GitHub. And so again, thanks for watching, and I'll see you next time. What a way to spend a Friday night.